post office box. This is another device which works on the Wheatstone bridge, and this is the exactly device which you will see in the physics lab, but here I will discuss with the circuit diagram. This is the circuit diagram. There is a branch AB in which there are three resistance: 10 ohm, 100 ohm, 1000 ohm. Another arm is arm BC, in which again we have three resistance, and according to Wheatstone we can say here is the resistance is Q. Then there is a arm AD which is having resistance from 1 to 5000 ohm, and one infinite is also there. I think it is not clearly visible, but this is the infinite symbol. Okay, now how it is like a Wheatstone bridge, firstly I will explain you. Between A and B we put any resistance P may be 10, 100, 1000. So I say this is A and this is B, and between A and B we introduce any resistance, that is denoted as P. Then between B and C again we can introduce any one resistance, either 10, either 100, either 1000 or 110, something like that. So suppose you say this is between B and C, resistance is Q. Then this from A to this long arm D, one resistance we introduce. This is the from A to D, and this resistance can be 1 ohm, there can be 3 ohm, 2 plus 1 can be 100, there is infinity is also there, there can be 200, any which we require. And between C and D there is unknown resistance X is connected, so you will connect the unknown resistance X like this. I hope now it is visible, it is Wheatstone, but we will complete it. Now galvanometer is connected between the, you see, from B to key, and this key is connected to galvanometer to point D. So I write here B, then there is a key, this key is K2, then galvanometer to D, this is K2, this should be straight wire, make it straight here. Okay, then where is this battery? All of you will observe this is A point to key K1, and K1 is connected to negative of the battery. It doesn't matter, it can be positive also. Here it will not affect if you can reverse the battery. So from A to key K1, then there is battery, again I am repeating, it doesn't matter, it is positive or negative, and it is connected to C. So I hope now it is clear to all of you. This device is exactly at the Wheatstone bridge, and when there is no deflection, P by Q equal to R by S, you can calculate. Okay, now I will explain the working. So very first step, I write here step 1. If I say P equal to 0 and Q equal to 0, I put P equal to 0, I put Q equal to 0, and we plug the key. Suppose we plug the key K1, then we plug the key K2, and we observe the deflection. Suppose deflection is towards left, like this. Then we plug the infinite key from this branch. If deflection reverse, deflection goes to right, it means our circuit is true, because we are able to get the null point. So first step is that to check the correctness of the circuit. Circuit is correct or not. This is the first step. Okay, now second step, step 2. In the step 2, suppose you introduce P equal to 10 ohm or Q equal to 10 ohm, like this. Now you apply the Wheatstone bridge principle, P by Q equal to R by S. Here it is X. So X can be written as R into Q by P. It means X, Q is 10, P is 10, so X equal to R. Okay. Now what you are doing in practical lab, between A to D there are number of resistance, and suppose we put 3 ohm resistance. Just I am taking an example. Suppose we use 3 ohm resistance in this A to D arm, and we see the deflection, and suppose I say deflection is towards left, and when we introduce 4 ohm resistance, we observe deflection in the galvanometer. Let deflection is towards right. Just let me complete it. Just a minute, I think there is some trouble in the software. At 4 ohm we say the deflection is toward right. It means the value of the unknown resistance should be between 3 and 4. Is it clear? So from step 2 what we get, value of the X may be between 3 and 4, but we don't know what is the exact value. Okay, then we are going to step number 3. In step number 3, let me write here, if we introduce P equal to 100 ohm and Q equal to 10 ohm, again we will apply the formula P by Q equal to R by S, that is X. X equal to Q into R by P. So we will write Q is 10, P is 100 and R, so it is R by 10. R by 10, in the last slide we have discussed that R can be between 3 and 4. In last slide we have discussed R was ranging between 3 to 4 ohm. Now it means here we should get the answer between 30 and 40. So suppose we introduce 32 ohm and we observe deflection that is left, and we introduce the 33, deflection is toward right. Again we are not getting 0 deflection. So when you put the 32 and 33 in this equation, you will get value of the X is between 3.2 to 3.3. In the first slide, in the step 2 we were able to reach 3 to 4 ohm. Now in this we are able to reach 3.2 to 3.3. Now we will go for the next step. Step 4. Let me write here. Step 4. Now we introduce P equal to 1000 ohm and Q equal to 10 ohm. Okay. So what is X? X can be written as, again I think I can directly write it, R into Q by P, so it is 10 by 1000. I will write R upon 100. In last slide I was able to calculate the value of the X is ranging from 3.2 to 3.3, but it is 100 times, R should be 100 times X. It means I should get the answer between 320 to 330. Is it okay? Suppose I plug 324 resistance in arm AD. I see the deflection is toward left. I plug the 326. I observe deflection is right. And I plug the 325. I observe that no deflection. It means what is the value of the X? X can be written as 325 by 100. It is 3.25 ohm. So this is the post office box in which we can measure the unknown resistance up to 2 decimal points. But please don't think that post office box is better than the meter base. It is not. Reason is that in this method accuracy will not perfect. What is the reason? Because resistance are of not same order, but in the meter bridge we were able to put the resistance of same order. So accuracy is not up to that, but if you want to measure the resistance up to 2 decimal places, you can use the post office box. Is it clear to you? Earlier it was used in post office. Basically what happened, suppose I say this wire is broken like this. Now this wire is grounded, potential becomes 0, and at C we create 0 volt, potential laboratory. Okay, now both the broken points are at the same potential. Again circuit is ready. Now we get the value of the X. X is unknown resistance. X is the resistance from this point to the wire which is at the ground. Now if we know the resistance per unit length, because already we people know it, what is the resistance per unit length of the wire which is connected between C and D. So resistance per unit length is known to us, and if X resistance is known to us, we can easily get the length at which there is breaking in the wire. So we can send somebody and we can get it corrected. But one more important thing I want to tell you. When we plug the key K1, this is the key K1, and if you plug this key K1, we have to plug it and we have to wait for some time. After some time we have to plug key K2. Reason is that there are number of gaps. I think these gaps are visible to you. In the self-induction chapter we will read that there is a coil in this gap, and when you plug the key, the current will flow in the coil, but in this coil we get initially some changing current due to self-induction, because we will read in there that if its coil is there, current cannot increase such a constant value at the instant. It takes some time to become constant, and reason is self-induction. But after some time, when current becomes constant, then we will plug the key K2. So again, please keep this in mind. When we plug the key K1, we have to wait for some time. What is the reason behind it? Because if we will wait for some time, in that time interval current will become constant, and after that we will plug the key K2 and we will use the circuit. Okay, so in this way we are able to complete this chapter. Now all of you go through the numerical video lecture also, so that you will strengthen your concept. Thank you.